All right, folks, one thing I actually forgot to include our introduction to Chapter 9, but that's okay. I just made another video. There's a kind of an unusual solution. You've seen this stuff. It's this beautiful blue stuff that we heated up. It's a solid. We heated it up at the beginning of the semester, and what you saw was water sort of came pouring out of this thing. So this is generally considered to be a liquid solute. Water's not the solvent, it's the solute. And the solid, the copper 2 sulfate, is the solvent, which is kind of cool. And that's pretty much all we're going to do is mention that sometimes an ionic compound that appears to be just a dry crystal or a dry powder is actually a solution that contains water as the solvent. Solute, excuse me, water is the solute. I better make a note. So that is the solute, strangely enough, and that is the solvent. We use this funny symbol, that copper 2 sulfate dot 5 waters. What it means is CuSO4 H2O 5. Now, the reason we don't write it that way is this implies that all these atoms are somehow bonded together. It's not. This is like an ion dipole connection that makes those there. They're temporary. Okay, the last thing I wanted to mention is often in the real world you're going to encounter something that looks like a solution, but it is not. And one interesting property of these things that look like solutions but they're not is in that YouTube video that those like high school kids made. So I put that right before this. So if you haven't done so, go back and watch the video. In the lecture, it precedes this. Watch that. And now that you've seen that, a solution, the solutes are atoms, ions, or molecules. It's that level. There's no like chunks of stuff. In something that we would call a suspension or a colloid, and there's a difference, frankly, but I'm not going to worry about it for Chem 51. The particles are, maybe 100 to maybe 10,000 times larger, the solute particles. This is the kind of drug or herbicide or something you'd use that says shake, because this stuff is in a suspension, it's large enough, colloid large enough that it can settle out. So it's like, you got to shake well. You go, this is not a solution if it says shake well. And one thing we noticed with a solution, you notice the kids were shining the light through, and you don't see the light. Just nothing. They had a laser, they're shining it through. But when they shined it through the suspension or the colloid, basically these block light. So you can see the light beam passing through, which is kind of a cool trick. So they shine the light through a solution, I think a sugar solution. It's completely clear. You can't see the light. They shined it through the colloid or the suspension, and you saw it because the particles are so big, they're actually blocking the light. So a solution does not have the same properties as a solvent, but for the most part, a suspension or a colloid has the same properties as the solvent. Now, we're not really going to study suspensions or colloids here because they're really a heterogeneous mixture. But just wanted to point out that sometimes in the real world, you're going to pick up a liquid and it looks like a solution and feels like a solution, and you have to shake it up and you go, wait a minute, this is not a solution. This is something called a colloid or a suspension. All right, I'll see you at the next page. Thank you, as always, for your patience.